Optics Lab is an Android application that simulates the refractive index experiment. This application was designed for students to help them visualize the path of light rays as it goes through different mediums. The following is a walkthrough for the application. The guide page contains a formal description of the physics experiment, along with a mathematical equation to calculate the angles. This application was designed and implemented in the German University in Cairo by 3 undergraduate students, as shown here in this page. This is the option screen. This screen allows the user to select the desired experiment parameters. The user can select a maximum of 4 mediums and a minimum of 2 in a single screen. In order to select the specific material, the user will use the drop-down menu as shown here. If the user wishes to show only 3 materials in the screen, then the user would select none for medium 4 as shown. There are 2 buttons shown on the screen. The first, labeled Start, will take the user to the experiment window. The second button, labeled Tutorial, will take the user to an interactive tutorial showing the different components of the experiment screen. This is the walkthrough tutorial screen. This screen was created to show the user the different components of the application. Each medium is represented as a rectangular block on the screen. The green border marks the intersection of the first and second medium. On the top right, there are 2 buttons, the refresh and back button. The refresh button will clear all the refraction and reflection rays drawn on the screen. The back button will take the user back to the options screen where the user can choose the number of mediums to display and the different mediums to display. The green box shown left shows the line separating the first 2 mediums. The user must select a point within the green box in order to determine the entry angle of the ray. This is the experiment start screen. On the left, we can see a silver sphere. This silver sphere marks the start position of the ray. The user must select a point within the green bounding box. Within the green bounding box is the boundary between the first and second medium. When the user selects a point outside of the box, he's presented with this message. Sometimes the user may select a point within the box. However, the entry angle produced will be too large, causing the ray to exceed the screen limits. The user is then presented with this message. Selecting a point correctly within the box will cause the ray to move as seen now. Underneath each medium is the medium's name and the refractive index of that specific material. The entry and exit angle of each medium is also written.